Hello guys, welcome to my YouTube channel Chem Discussion. Now I am going to discuss Sonogashira coupling, which is an very important coupling reaction catalyzed by palladium, and it is introduced by Kenkichi Sonogashira, and it is very similar to Castro-Stevens coupling. In Castro-Stevens coupling, aryl halide is coupled with copper acetylide under very drastic condition, usually pyridine refluxing condition. It gives disubstituted alkyne, but the Sonogashira coupling reaction has a very advantageous features that it can be performed in very mild condition. So that's why Sonogashira coupling reaction is very famous. Now in Sonogashira coupling reaction, two coupling partners are terminal alkynes and vinyl halides or pseudohalides. So that means one is, suppose, aryl halide or pseudohalide, another one is alkynes. So basically they are hydrogen and another substituent, and in presence of palladium catalyst, and here copper 1 is used as a co-catalyst and a base is used. So by that way we get this disubstituted alkyne product. And if haloalkene is used as a substrate, its geometry is preserved in the product. So these are the basic features of Sonogashira coupling, what we actually see when we perform it. Now we will see that what is the catalytic cycle of this coupling reaction. So in this coupling reaction, palladium 0 is the active species which undergo oxidative addition with aryl halide or pseudohalide. After that it gives trans oxidative additive product. That means after oxidative addition, the aryl halide added to the palladium complex in the trans fashion. After that transmetallation occurs. In the transmetallation step, the copper alkylide is formed by the help of copper halide and a amine base. And here is the role of amine is, first it deprotonates alkyne to give anion over there, and then the copper is forming the copper alkylide, and after that this copper alkylide participates the transmetallation step to give this intermediate. Here one thing you should notice, that the aryl group and the alkyne substituent, those are trans to each other. That means those are far away from each other. But we know that for reductive elimination there is a prerequisite condition, is that the both substituent that is going to give the reductive eliminated product, that should be in cis fashion. So before going to the reductive elimination, the trans, that means trans to cis, here the aryl group and the alkynyl group is cis to each other, that means trans cis isomerization occurs. Why it is isomerization? Because all the things are same, only the groups are rearranged with each other. Then after reductive elimination, it gives the disubstituted alkyne. So palladium 0, after oxidative addition, it gives a square planar complex where aryl halide is oxidatively added to the palladium in the trans fashion. Then transmetallation occurs. In the transmetallation step, copper acetylide or copper alkylide is formed, and then the transmetallation step happens, and then trans cis isomerization occurs before going to the reductive elimination. So by that way, actually the Sonogashira coupling reaction happens. Now we will see a lot of examples. So first we will see, I have told that in the haloalkene the geometry is very much preserved in the product. Here if you see, the dichloroalkene is the G conformation, that means its geometry is cis in a simple language. In the product also, the alkyne and the remaining chloro group is very much cis to each other, and all the condition is very much similar. Here actually this butyl amine or the amine is used to perform the reaction in lower temperature. So subsequently, if you see this example, you will see that in the product the geometry is preserved. Here trans substrate is used, and we have got the trans product. Now we will see another example. In this example, this is very simple. There is two substituent, one is amine and one is iodine. We know that iodide is reacted with alkyne. Here the trimethyl silyl substituent is present. Under the Sonogashira condition, it gives alkyne product. If you treat it with strong base or different fluoride source, you will get hydrogen over there. That means you will get a terminal alkyne. And if you, here we will discuss the another example where the dichlorosubstituted alkene is used and 2 times alkylation occurs under Sonogashira condition, and the yield is very good. So these two are a very good example. Now we will see another example. Here the terminal alkene is used, this terminal alkyne, and here this iodide is used, and under this condition it gives this product. And then this is also a very good example if you see, and here the bond formation occurs, that means coupling product. Now if we will see two different examples, here after the Sonogashira reaction, the Sonogashira product is used in another reaction. One is the very much famous, which is Bergman cyclization. Here first in diene is produced by 2-time Sonogashira reaction, and after that if it is heated or if it is treated in the thermal condition, it gives a very uncommon or rare, you can say, intermediate. This is called parabenzene. And this parabenzene intermediate is very much reactive. It can abstract H dot to give a aromatic ring. Even it can abstract chlorine from carbon tetrachloride to give here dichloro product. That means it is a very important reaction. Now we will see a very different example, that is a unactivated aryl substrate, an unactivated halide substrate. Here the carbon is very much sp3. Till now what we have seen, that every carbon or every halide substrate was the sp2 hybridized. Here first time we see that the halide is very much unactivated and the hybridization is sp3. Now here, under the presence of n heterocycle carbene, it gives the sp3 csp3 and csp coupled product. That means this one is very much sp3 carbon and this one is very much sp carbon. So it is a very good example, and that's it for today. And subscribe my channel, press the notification button. Thank you.